Hello, class. In this video, we will study the continuous probability distributions by focusing on the normal distribution, arguably the most important distribution in statistics. A continuous random variable is a random variable in which the data can take infinitely many values. For example, a random variable measuring the time taken to complete a task is continuous. Since there are an infinite number of possible times that can be taken, the thickness of an item, temperature, and height are all continuous variables. A probability density function, PDF, or density of a continuous random variable, is a function of the distribution of a continuous random variable. A random variable with Gaussian distribution is said to be normally distributed. The distribution is widely called a normal distribution. Normal distributions are important in statistics and are very often used in the social sciences and the business world to represent real values, random variables, whose distributions are not known. For example, the normal distributions have been widely used for variables such as height, IQ, and profit returns. It is useful in problem solving involving large numbers of data. The normal distribution is characteristic, symmetric, bear-shaped, and has a single peak at the center of the distribution. It is asymptotic, meaning the curve approaches but never touches the x-axis. The location of a normal distribution is determined by the mean, which is in the center of the bear-shaped curve. The dispersion or spread of the distribution is determined by the standard deviation. The normal probability distribution has a complex formula to find probabilities. But given that the two parameters, pi and e, are fixed, the normal distribution is completely described by its mean and the standard deviation. There's not just one normal probability distribution, but a family of them. In this chart, documenting the tensile strength of 3 different cables, we see they have different means and different standard deviations. For example, comparing to the first one, the second one has a large mean and a higher standard deviation. The third one has a higher mean but lower standard deviation. The area below the curve defines probabilities, and the total area under the curve is 1.0. Therefore, the area to the left of the mean is 0.5, and the area to the right of the mean is 0.5 as well. The number of normal distributions is unlimited, but they can all be converted to a standard normal probability distribution. By standardizing a normal probability distribution, the distance of a value from the mean can be expressed in units of the standard deviation. The results are called z-values or z-scores. Mathematically, the z-score is given by z equal to x minus mu over sigma. The standard normal probability distribution has a mean of 0 and a standard deviation of 1. The z-score is the distance measured by the number of standard deviation from the mean. We now show how to compute for the Z-score for drivers in a rideshare company. This rideshare idea was first developed by Uber Technologies, which is headquartered in San Francisco, California. Following the definition of Z-value, we can then obtain the Z-value of an income of $1,100, which is Z equal to X minus mu over sigma equal to 1100 minus 1000 over 100 equal to 1. For an income of 900, we have Z equal to X minus mu over sigma equal to 900 minus 1000 over 100 equal to -1. A Z of 1 indicates that a weekly income of 1100 is 1 standard deviation above the mean. And a Z of -1 shows that a 900 weekly income is 1 standard deviation below the mean. Both incomes are the same distance from the mean, but in different directions. The empirical rule of Z-value states that for a standard deviation away from the mean, the Z-value is equal to 1.00, which corresponds to a probability of 0.3413. So plus and minus 1 standard deviation from both sides is 0.3413 times 2 equal to 0.6826, which is approximately 68% of the observations. A Z of 2 corresponds to 0.4772, so plus and minus 2 standard deviations from both sides equal to 0.4772 times 2 equal to 0.9544, or about 95%. And a Z-value of 3 corresponds to 0.4987. So plus and minus 3 standard deviations on both sides equals to 0.4987 times 2 equal to 0.9974, or about 99.7%. Due to the complexity of the normal distribution function, we usually use the normal distribution table, also called Z-table or Z-score table, to obtain the probability of a given observation based on its Z-value. For example, suppose we want to find the probability for a sample with a Z-value less than 0.83. In this given Z-score table, we first find the 0.8 in the first column, and then find the remaining value of 0.03 in the first row. Then find the intersection of the 0.8 row and the 0.03 column, which give us a probability value of 0.7967. Using the Z-table, theoretically, we are able to find the probability of any given area of a normal distribution, such as from point A to point B, based on the mean and standard deviation information. Because normal distributions are for continuous variables, practically, the probability of any individual value converges to 0. Mathematically, we may say that probability of x equal to A equal to 0. So we have probability of A less than or equal to x less than or equal to B equals probability of A less than x less than or equal to B equals probability of A less than or equal to X less than B equal to probability of A less than X less than B. So when looking for the probability of a continuous variable, we always look for the probability of an area rather than a single point. To find the area between 0 and z or negative z, we may look up the probability directly in the z table. We know that the probability of finding a driver that ends less than 1000 is 0.5. That is, z value equal to 0, because 1000 is the mean value. In this example, the probability of finding a driver that ends less than 1100 is 0.8413, given that the z value is 1. So the probability of finding a driver that ends between 1000 and 1100 is 0.8413 minus 0.5 equal to 0.3413. Therefore, 34.13% of drivers ends between 1000 and 1100, and 84.13% of the drivers end less than 1100. Let us look at another example, finding the value for probability of 840 less than or equal to X less than or equal to 1200. In this example, we combined two areas or probabilities under the curve. One area to the right of the mean and one area to the left of the mean. To find the area between 2 points on different sides of the mean, determine the z values and add the corresponding probabilities. The z value for 840 is given by z equal to x minus mu over sigma equal to 840 minus 1000 over 100 equal to negative 1.6. The z value for 1200 is given by z equal to x minus mu over sigma equal to 1200 minus 1000 over 100 equal to 2.00. Checking the z table for the z value of negative 1.6, the probability of the weekly income less than 840 is 0.0548. So probability of 840 less than weekly income less than 1000 is equal to 0.5 minus 0.0548 equal to 0.4452. Similarly, checking the z table for the z value of 2, the probability of the weekly income less than 1200 is 0.9772. So, probability of 1000 less than weekly income less than 1200 is equal to 0.9772 minus 0.5 equal to 0.4772. So we have probability of 840 less than weekly income less than 1200 is equal to 0.4452 plus 0.4772 equal to 0.9224. In fact, we can more easily obtain the same value if we use 9772 to minus 0.0548 directly, we can obtain the same probability value of 0.9224. Therefore, in either way, we obtained that 92.24% of the drivers have weekly incomes between 840 and 1200. As previously discussed, we can use the value of an observation X to find the value of Z. Reversely, we can use the Z value to find the value of X. In this case, Leighton Tire and Driver Company wishes to set a minimum mileage guarantee on its new MX100 tire. Tests reveals the mean mileage is 67,900 with a standard deviation of 2,050 miles, and that the distribution follows the normal distribution. Leighton wants to set the minimum guaranteed mileage so that no more than 4% of the tires will have to be replaced. The question is, what minimum guarantee mileage should Leighton guarantee? Given that Leighton wishes to replace no more than 4% of the tires, we examine the probability point of 4% on the left tail of the normal distribution. So the distance from this specific point to the mean is given by 0.5 minus 0.04 equal to 0.46. Theoretically, we can look at the negative z-score table, but due to symmetry of the normal distribution, we may also look at a z-table with positive values of z. Using the z-table based on a probability of 0.46, we identify the z-value to be 1.75. As we can see from this z-table, we treat 0.4599 as an approximation of 0.46. And we get a z-value of 1.75. Symmetrically, on the left tail, the z-value is negative 1.75. We then replace this z-value of negative 1.75 in the following equation. Z equal to x minus mu over sigma equal to x minus 67,900 over 2050. And from the table, we find z equal to negative 1.75. So we have negative 1.75 equal to x minus 67,900 over 2050. Then we can obtain that x equal to 64,312 miles. Therefore, the minimum guaranteed mileage should be set at 64,312 miles, so that only 4% of the tires will be replaced under this plan. Typically, we know the population standard deviation when we have a long history of collected data. Knowing the population standard deviation allows us to use the standard normal distribution. For a normal population or a big enough sample, typically larger than 30, we will explain why later. We can also define the concepts of confidence interval. Typically, a 95% confidence level means that we are 95% certain that the true value of the mean lies in the range of x bar minus 1.96 times SE, comma, x bar plus 1.96 times SE. The value of 1.96 is the z-value. SE is the standard error, where the standard error is given by SE equal to sigma over square root of n. N is the sample size. In other words, we are 95% certain that the true value of the mean lies in the range of within 1.96 standard deviation away from the expected value. We can also use Excel to compute normal probabilities. For example, in Excel, we have probability of capital X less than X equal to norm.dist of X, mean, standard deviation, and 1. 1 is the cumulative probability of normal distribution. For a given probability, we can also find the value of X using X equal to norm.inv of alpha, mean, and standard deviation. In the following, we have several examples. For example, in this case, we try to find the probability of X less than 8.6, and we can call the norm.dist of 8.6 and mean value of 8, find the standard deviation and 1, and we get 0.5478. In another example of a probability between 8 and 8.6, we can have the probability of 8.6 minus the probability of 8 to get 0.047. Suppose we have the probability information 20%, and we use these equations try to find the value of X. And in this case, X equal to norm.inv of 0.2, 8, 5 equal to 3.8. We are going to use Excel file to show the process of getting this value again in this Excel file. Okay, so let me repeat these 3 examples. X is the time to download a movie from the internet. And we suppose X is a normal distribution function with mean 8.0 minutes and a standard deviation of 5.0 minutes. Our target is to find the probability of X less than 8.6. It means to find the probability that your download time of a movie is less than 8.6 minutes. I already copied the graph and the information from the slides. But here I'm going to demonstrate this equation pretty much the same, but we are going to type in that is the probability we are going to find, right? So I'm going to say probability equal to, or you can put it a little bit more detail, less than 0.6 and equal to. You can put return, and I'm going to use another cell to store the value of this probability. So in this cell, I'm going to put equal at first. I'm going to put norm.dist. Actually, in Excel, you're going to see the pop out of norm.dist directly. When you put parentheses, you can see it pop out a reminder of those parameters of this function. And the first value is X. We already know we want to compare to 8.6, comma. The mean value is given by 8, as we know in the question, and we have the standard deviation of 5, right? And the cumulative probability of normal distribution function is given by 1 by default, and we have this. So after we say return, we have the probability of 0.54, 77, 58, and actually that is the about the same value I type in the slides. Okay, so this is for the first example I shown quickly in the slides, but here I just do it a little bit slowly so that you can follow me in the Excel file. So far, if you have not opened the Excel file yet, probably you can take time to open it and try to repeat what I have just done over there to make sure you know how to utilize this equation. Of course, we can try that in the second example. Of course, please open your Excel file and follow me step by step here. So now let X be the value again to download the movie from the internet, and our target now is try to find the probability of download time between 8 minutes and 8.6 minutes. So kind of we try to find a probability in an area. So as I already explained, the probability between an area, we are going to get the probability from one point minus the probability of the other point. So it's from the higher point, 8.6, minus the probability of 8. So we have a large area minus the smaller area. So we have the kind of the leftover area will be the probability from A to 8.6. Okay, so now how can we do that? We are going to, again, you can type in, where is, you're going to type in any area. But let's try to put probability of 8 less than X less than 8.6 at first. Okay. And I'm going to select this cell. Okay, so in this cell, I'm going to type in the equation we want. As we know, we are going to use 8.6 probability point. So that will be equal to norm dot dist, and that will be 8.6 and comma mean, comma standard deviation, and comma the cumulative function of 1. And that is only the upper point. So we need to minus the norm dot dist. The second point is 8, mean of 8, and comma standard deviation of 5, and comma 1. So we pick the cumulative property function all the time here. So we say return, and we get 0.0477 for this probability. So as we can see, the previous value in the slides is an approximated value from what we get from the Excel. So Excel give us a little bit more details. So far so good. Hopefully you are following me in Excel right now. So let's try to go to the third example I show in the slides. Again, the movie information is by default the same. Now we try to find the value of X such that 20% of the download time are less than X. So there will be X, 20% of download time will be less than X. So we want to find the value of this one. But we know that that's 20%, right? 20% of the probability. So now we are going to temporarily put on here. Our target is to find the X value. So we go to another cell and we say equal. We already know that this is inverse function. So we are going to have norm dot inverse, and to the value of 20%. 20% is 0.2. And we call the mean value 8, comma, we call the standard deviation value 5, and we have this equation ready. So again, this will be equal to norm dot inverse of 0.2, 8, 5. And we say, okay, so that will give us a value of 3.79189, something like that. Again, this give us a little bit more detail than the value I provided on the slide. So I hope you now know how to use Excel to get the value based on the normal distribution function equation in Excel. In this video, we introduce a normal distribution function, the empirical rule of z-value, standard normal distribution function, and the z-value. We also learn how to find normal probabilities and find a value for x using z-value. We discuss confidence intervals and use Excel to compute normal probability. Again, it's very important to practice, and please write down the detailed logic when you practice on the quizzes, and also for your future reference.